Forensic Science Lecture 1-3, Functions of a Forensic Scientist. Forensic scientists rely primarily on the scientific knowledge and skills when they're analyzing the evidence that they've collected, but not all of the work is actually done in the lab. About half of it is done in a courtroom. And this is where ultimately the significance of the evidence is determined. So it could be the smallest piece of evidence that hits the jurors with the most impact to convict or to not convict. So when they're analyzing the physical evidence, there are three avenues that are available to all police when solving a crime. Everything from the physical evidence to a confession and the eyewitness accounts. However, it's only the actual physical evidence that is free of any sort of inherent errors or bias, because we are human, and humans make mistakes. They can be confessing for somebody else to cover up from somebody else. Eyewitness accounts are actually not very reliable. There are things that are missed. It's just the way that our brain is working, or works, and what we can remember. Although some people, say, "Oh no, I remember everything to detail." It's pretty amazing of how inaccurate they can be. But the the physical evidence has to go through scientific inquiry. And because of that, it ensures that the outcome of whatever that is, whether it's on the side of the defendant or on the side of the prosecutor or the victim, the outcome is not tainted in any way by emotion. It's not compromised. And there are strict guidelines that each scientific inquiry has to follow. And those guidelines are the scientific method. The steps of the scientific method, there are 5 steps to it. First is the formulation of the question. The crime scene, who did it, what happened, and so on. And then a formulation of the hypothesis. So it needs to be a testable hypothesis. Once the hypothesis has been formed and a test has been created, it then goes through the experimentation to see what that outcome is. One scientist, one lab is not enough. It's never enough. So scientists and the other scientists involved and investigators must accept the findings. Regardless if it is what they thought or what they hoped, they have to accept the findings of the experimentation. And it needs to be retested. Once it has been evaluated by peers, so the scientists, investigators have accepted it, it is then considered to be suitable for admission in court. So when we talk about admissibility, that's what it means. Is it suitable for court? Is it going to have any sort of merit during the court case? In the early 1900s, there was a court case, Fry versus United States, and they determined the guidelines for determining the admissibility of a scientific evidence. And basically what it landed on was, is this generally accepted by the scientific community as evidence, as concrete? But by 1993, there was a Supreme Court decision that said that the Fry standards of admissibility is not always absolute. And what they did was they gave the trial judges the ultimate responsibility of determining whether or not something was admissible. and valid evidence for that court case. It also gave the trial court judges responsibility for admissibility of an expert testimony, which we'll get into in a little bit. So judging scientific evidence, they didn't just leave it completely up to the trial judges, but they set forth some guidelines to kind of for them to gauge it, and it's whether the scientific techniques or theories can be or has been tested, whether the techniques or the theory has been subject to peer review and publication, what the potential rate of error is for those techniques, because no matter how hard they try to make sure that there's no errors or availability of errors, it happens. They still can usually have a small margin of error. Also, the existence and maintenance of standards controlling the technique operations. So, is the equipment up to date? Is it constantly being maintenance? And then whether the scientific method has attracted widespread acceptance within the relevant scientific community. So again, it's based on that scientific community, on is it widely accepted. Okay, once the evidence has been analyzed, it's typically the scientist's job to provide an expert testimony. And an expert witness is someone who possesses a particular skill or has knowledge in a trade or a profession that will aid the court in determining the truth. Okay, and so trial courts have a broad discretion in accepting an individual's expert witness, but typically in that process of determining if they are reliable, the questions are going to be asked intended to demonstrate this individual's ability and competence. It could be anything from the degrees that they hold, any membership of professional societies, participation in any sort of special courses, books or articles they may have published. It could also just be the amount or the number of years of experience that they have. So they put them through some pretty hard questioning, but they want to make sure that they are an unbiased witness. The other thing with an expert testimony is experts cannot render any view with absolute certainty. At best, it's an opinion based on scientific certainty derived from training and experience. But again, it's got to be very straightforward. It's not I feel, it is this is what the evidence shows. In order to actually have the evidence, the proper evidence, there has to be proper training in the collection portion of it. So the competence of the lab staff, it has little value if the relative evidence is not collected, if it's not recognized, collected, and preserved at the crime scene. And to ensure proper response, especially trained evidence collection technician is or can be dispatched to the scene. Evidence technicians are kept on call by many police departments to retrieve evidence at any given crime scene. So this is 24 hours. But those departments that don't have the technician will have a patrol officer or a detective that has been trained in the collection process. Technicians are typically trained by the crime lab and will always have proper tools at their disposal. But This is the first site, the first place that the evidence comes from. And so the individual needs to be able to recognize what's the important evidence. They need to know how to collect it so it's not contaminated and how to preserve it to get it to the lab where that can then be evaluated. This is our section 3 slide. We will have, or lecture, we will have a quiz next class.